Hi, welcome back to AT Math. Today, 11.5, square root functions. Now, you've seen this before. We're just going to do a basic overview. A square root function simply means there is a value under a square root. And when you get that value, you simply root it, and there you go. The long story about this here is in NASA, they practice by having astronauts do, practice what they do like in space. They take a large aircraft, I guess the KC-135, and then they go all the way up and they just let it free fall for like a few minutes. Maybe they can get like 5-6 minutes before they have to come back up again before they hit the ground. Well, in that 5 or 6 minutes, astronauts are basically in free fall, where they can, and they are basically weightless. So they learn what it's like to be in a weightless environment. And it's funny, they call the KC-135 the vomit comet because a lot of astronauts get sick with the violent up and down swing. But, if you're having trouble with that, that's the first thing that's going to happen when you're in the space shuttle going up into space, or in a rocket going into space. You're going to have that giant thrust. So if you're going to have trouble, they want to know about that early. Anyway, the feet per second of an object in free fall is 8 times the square root of x. So that's the figure they use. Now, let's just take one first, and we'll go back to this. So let's say that an object falls just 4 feet. Well, you take 8 times the square root of x, and x now is 4. So after 4 feet, take square root of 4, which is 2, and take 2 times 8, which is 16. So basically, after an object falls for 4 feet, it's going 16 feet per second. Now take a look here. What is a square root function? It simply means that an x is underneath the root. Now, it may not be the only thing underneath the root, but it is under the root. Take an example here. You have x here, x here, x here. In each scenario, an x is underneath the square root. There might be by itself, there might be more there. There might be more afterwards, but x is under a root. Take a look at these non-examples. All 3 of these x is not under a square root. That's why that doesn't count. Now take a look at this here. Again, 8 square root of x. We'll say an object falls 50 feet, so you root 50. Now when you root 50, you'll know, okay, that's not exactly a whole number, because it's like square root of 49 is 7, but square root of 50 is going to be like 7.1 and some change. Well, you root 50, which is 7.1 something, times 8, and you'll get 56.6. Finding the domain of a square root function, basically y equals root of x plus 4 minus 3. What you want to do is define a domain. Basically, domain means all possible numbers. And the domain is for the x value, where y, of course, is the range. Well, the only thing you have to not have is you can't have a negative value under a square root. Because remember, we talked briefly about it a couple of chapters ago. That becomes an impossibility until Algebra 2, when you learn that the root of a negative number is what they call I, or imaginary. But we're not going to worry about that. For now, we'll say that the root of an x simply has to be a 0 or greater value. So we're going to take this whole thing here, which is square root of x plus 4. And all we're saying is that all this has to be 0 or more. It simply can't have a negative value. So you simply plug it in as such. You go ahead and say, well, x plus 4 is greater or equal to 0. To get x by itself, is a plus 4, minus 4 on this side, minus 4 on this side. X is greater or equal to negative 4. So the domain of the set of real numbers greater or equal to negative 4, meaning it can be any possible answer as long as it's negative 4 or more. You try. Find the domain. In other words, go ahead and put this greater or equal to 0 and find what the x can be. Go ahead. Let's see how you did. First thing I did, when you have 3 times x minus 2, is take 3 times both of them. So 3 times x is 3x, 3 times negative 2 is negative 6. This entire value has to be greater or equal to 0. So you have this here. Instead of minus 6, plus 6 to one side, plus 6 to the other. 3x is greater or equal to 6. Divide both sides by 3. In other words, x is greater or equal to 2, meaning as long as you have a 2 or larger value, that's going to fit this particular equation. If x is less than 2, then it's not going to work because you have a negative root, and you can't have that. You try. Go ahead. Alright. 2x minus 1 greater or equal to 0. Add 1 to both sides. You got that. Divide by 2. X is greater or equal to 1/2, so yes, x is greater or equal to 1/2. So as long as it's 1/2 or more, you're fine. Now the parent function for square root functions, f of x equals square root of x, is graphed to the right. Basically, it's bending slowly. Unlike an x squared that shoots straight up fast, x root does the opposite. It shoots up and then it slowly increases. Now why does it slowly increase? Because think of a number you root. let's say the root of 4 is 2, and the root of 16 is 4, and the root of 49 is 7, and the root of 81 is 9, root of 100 is 10. So basically in the beginning, roots are pretty simple. They're pretty close to what they started with. By the time you get to 100 though, 100's way up here, roots down to a 10. So it's basically, it starts normal but then slowly increases. Let's say because the root of a million is 1,000. So you have to go way high up to get that root value of the next thing. So basically this is the general shape. Starts off normal and slowly peters out. So you go ahead here, root of x and plus c, in other words the value. Remember the y-intercept. So root of x is right here, that's the blue line. Root of x plus 2, you start at positive 2, and then you root off. Square root of 8x, square root of x plus 4, start at plus 4 and root off the x. Square root of x minus 1, go to minus 1 and square root of x. And then this is a little different. Now what we have here is you have a root, but because the root is the plus or minus on the inside, you're actually going to be doing the opposite, which we'll explain why. So square root of x plus 4, you actually start at negative 4. Now why do you start at negative 4? If you plugged in a negative 4, negative 4 plus 4 equals 0. Therefore, when your x is negative 4, your value actually y is 0, because when you plug negative 4 in, they cancel out. Same with this here. X plus 2, well, the negative 2 would make negative 2 plus 2 is 0, so at x value of negative 2, you get a y value of 0, and so on. Take a look here, root of x minus 4, you do the opposite of whatever you have here, so instead of minus 4, it's going to be plus 4, so you start the x value of plus 4. And that's where you'd start off at. Because if you plugged in a 4 here, 4 minus 4 is 0, therefore if you plug in an x value of 4, the root becomes 0, and that's why. And then you just have your basic increase. You try. Go ahead and graph. Root of x plus 2. Go ahead. Let's see how you did. Remember to do the opposite. So plus 2, you're going to minus 2. So start at 0, 0, and go to the left 2. And then you make your normal increase for x squared. X root, excuse me. Now, if it is outside the square root, then it's just the y-intercept. So remember you have the plus 2. Well, it's outside, so you're just going to go up 2. Then your normal square root of x. Like this. You do up and down 2. How do you do that again? If it's outside the root, it's up or down. If it's inside the root, it's left to right, but it's the opposite. Now, when you have both, however, I would start with this here. You have the plus 3, so I'm going to go ahead and go up 3. Then, inside there, remember you have to do the opposite. So instead of going plus 2, you're going minus 2. So you are going up 3, then you're going left 2, which is right here. Up 3 and left 2, and from there you start your root of x. Like this. Now, a thing to understand, remember, you can't have a negative root value. So x has to be negative 2 or more. That's why it starts right here. The x value can keep going to the right, but it can't go to the left. It actually has a dot because it's stuck. It can't go to the left because it makes a negative value. So it actually starts at x equals negative 2 and gets larger as it goes over. And finally, y equals 3 to the square root of 3x. Basically, square root of x, you have the normal, square root of 3x, which I kind of free-handed, which wasn't so great. And basically, 3x, whatever number you have, you're going to times by 3 and then root. It's going to be 3 times as large, but it still gets rooted down the same. It still slowly ebbs and doesn't, get as tall as quickly because again, it's a root, so it's going to drop it back down. So simply, it's going to be a larger version of a root. And there you have it. We'll do some more in class. We'll definitely do some graphing, probably some whiteboards. Thanks again. Bye.